Hey guys, today we're going to go over some 4 to 20 milliamp circuits. First, let's go over what a 4 to 20 milliamp circuit is. I'm going to read it pretty much word for word here. A 4 to 20 milliamp circuit is an analog circuit commonly used in industrial automation and control systems to send signals representing a range of values from a sensor or transmitter to a controller or display. In this system, the current varies between 4 milliamps, which represents the lowest value in range, to 20 milliamps, which represents the highest value. There are two major advantages to using a 4 to 20 milliamp circuit. One is current signals are less affected by electrical noise over long distances. The second is, and this is great for technicians, a signal lower than 4 milliamps, such as 0, indicates a broken wire or fault. Let's briefly just go over what I mean whenever I say a 4 is the lowest value and a 20 is the highest value whenever you're representing a range. So you have a tank and you're trying to read the level of it. If you're reading 4 milliamps, that should mean that the tank is empty. 20 milliamps means the tank is full. 12 milliamps, which is right in between 4 and 20, means the tank is halfway. This is much more beneficial than just float switches saying, I'm all the way up or I'm all the way down. This gives you an accurate range, especially if you have a huge tank. Okay, let's go over what we're looking at on the screen right here. On the very right where it says analog input, that rectangle represents a input card. And on terminal 1, that's going to be our positive. On terminal 3, that's going to be our 4 to 20 milliamp signal. And terminal 2 at the bottom, that's going to be our negative. The black lines there, those are indicative of the wires that are going to be coming from the field device into the cabinet that's located close to the PLC that has all the input cards. The important part is whenever we troubleshoot this thing, we need to, if we don't have a process clamp meter that can read 4 to 20 milliamps, we're going to have to break that 123-C line, and I'm going to show you a visual representation here. Okay, now you can see that we physically lifted the wire from the number 3 terminal from the analog input card. You're going to literally have to have your screwdriver push it into the number 3 terminal, and either there's going to be a screw you got to loosen up or just press it in like a press fitting. And then once you lift that wire, we're going to get to the next part. Okay, you might think that this is hilariously crude, but the red rectangle represents the meter and the red lines represent the test leads. If you see here, we're not just touching off like we would normally do in parallel if we're going to measure voltage. We've actually got the 4 to 20 milliamp circuit traveling through our meter here. And you have to do that when you read 4 to 20 milliamp. Also, I'm going to show you right here, you've got to change your leads from common and voltage to common and milliamps. Also, it's very important to note that you need to have your selector also on the milliamp selection as well. I plan on taking some future videos in the field with my meter, showing you really what's going on. It's a lot better than these paint pictures that I'm trying to work with here. Another quick thing I want to hit on is we've been talking about what happens with a 4 to 20 on an input device, or anything inputting information to a PLC. Well, the PLC can also output a 4 to 20 milliamp signal to something like a proportional valve that controls hydraulics. And this situation is a little bit different because a proportional valve has an A and a B side, say for a direction, and the very middle is closed, so no movement. So then it's actually 12 milliamps is going to be closed, and then say 4 milliamps is A side all the way open, and 20 milliamps is B side all the way open. This is pretty common with a lot of proportional valves in factories and things, and definitely very important to get to learn how to troubleshoot that, especially if an operator states that the valve, or he's not necessarily going to say that the valve's not opening all the way. He's going to say whatever the valve controlling is not working correctly. At that point, you're going to need to see what the PLC is actually trying to output. So if it's actually trying to go 100% open on B side, and you know that means you're supposed to be getting 20 milliamps, you're going to have to go out to the card there or out to the device and either put a process clamp meter on. I could put one of those up right here. It actually reads the 4 to 20 milliamp. If not, you're going to have to break the circuit and put your standard meter in series with it, measure it, and see what's going on here. Because if you're outputting the correct milliamp to the valve and the valve's not working correctly, then you're either going to have to change the valve, or maybe there's actually a hydraulic issue. Alright guys, so we've went over a few of the basic things of a 4 to 20 milliamp circuit. Definitely didn't go over a lot of it. Like I said, it's used in the industrial environment everywhere with instrumentation. There's a lot more to go into it as far as general calibrations and general ways that you can check your ranges to what you're actually measuring, like fluid level or pressure versus your 4 to 20 milliamp range, and verifying it. We'll go over that in the future. Like I said, right now I'm just trying to hit some of the basics and just get some content out for you guys. So if you do me a favor, and if you really enjoy watching this video, just give me a like, and I appreciate it. See you later.